Welcome everyone on today's EAStalk webinar with Dr. Chris Noble. Thank you for joining us today, and apologies for scheduling the webinar. We hope it was not a big issue for each of you. Dr. Chris Noble is a senior scientist within the production biology department of Nofima. The majority of his work focuses on fish welfare in aquaculture, primarily development and application of operational welfare indicators for different species, routines, and rearing systems. Chris E.'s presentation will discuss operational welfare indicators, the tools we use to assess fish welfare out on the farm. He will give an overview of the tools we have, how they are being developed, refined, and improved, and how they can be used in differing aquaculture situations. The digitalization of operational welfare indicators and the application and evolution of welfare indicator toolboxes will be also covered. My name is Anna Viskovic, and today I will moderate the session. This webinar will last for approximately 45 minutes with 30 minutes of presentation time and 15 minutes for questions and answers. During Chris' presentation, you can send us questions in a private message referring it to Anna or to everyone. Once the presentation is finished, you will be able to discuss your questions directly with Chris. So please let us know in the message if you would prefer that your microphone is unmuted. Furthermore, after the question and answer section, we will have 3 short questions feedback. So Dr. Noble will share the slide at the end of the presentation. Dear Dr. Noble, thank you so much for accepting the invitation to present the work. We are looking forward, so please feel free to start presenting. The floor is yours.
Perfect. Thanks so much for the introduction. I'm just going to let me know if can you see the presentation okay?
Just a second. I can see your yes, now it's good.
Perfect. So yeah, thanks so much for the introduction and the invitation to speak here today. And as Anna said, the presentation I'm going to give is about the evolution and application of aquacultural OWIs, operational welfare indicators. So these are the tools that we use to assess fish welfare out on the farm. So I'll discuss what they are, potential future developments in the field, and basically how to use them, for example, in decision support and planning. The presentation will have a bit of a heavy bias on salmonids and also the work I'm involved in. But hopefully it can give insights in how to adapt the OWI frameworks we're working with, applying them to different species and the various life stages. That's incredibly important. And also the differing welfare challenges that require different species and life stage specific OWIs and OWI toolboxes. And the theme that I'll come back to throughout the presentation is refinement once again, both with regard to the tools we use, how we apply them, how we combine them, and then how we interpret their application. So I'll start the talk with a general description of fish welfare, a little bit on the theory behind it for those who are unfamiliar with the subject, and then I'll launch into the main topic. So basically, what is fish welfare? There's a lot of definitions out there, and we still don't have full consensus on a standard definition, but the one that a lot of people are working with now is a quality of life definition, which is the quality of life as perceived by the animals themselves. This was first introduced to salmonids by Lars Steen in his swim model paper in 2013. And it's a simple, intuitive definition, and it's a good platform to take the discussions further and identify threats to fish welfare and also address the aims of improving the life of fish out on the farm, giving them a life worth living. But what does it mean in practice? you've got various frameworks addressing welfare needs. There's the 5 freedoms approach and also this 5 domains approach, which I'll go through here. And the 5 domains approach involves 4 categories of welfare needs. This is one based on salmon, but the framework can be adapted for other species and also animal production species, terrestrial, not just aquaculture, so long as you account for the species and life stage specific welfare needs as we know them right now. And needs can be based on the resources the fish have, the environment they're subjected to, and also the health and the behavior. All of these contribute to the mental state of the fish and ultimately its welfare state. And basically, good animal welfare means that all or the majority of the animal's welfare needs are fulfilled. So now we have the definition and a potential framework. Now we need some tools to measure it. And the tools we use to measure welfare are called welfare indicators. And we have various classes that have been developed over the years, and some of the ones we've worked on recently. And you can start with categorizing them in 2 ways in aquaculture. You can look at operational welfare indicators. So those are suitable for on-farm use. So they have to be robust, repeatable, provide a valid reflection of welfare, comparable, and relatively easy and clear to measure. We used to say that in earlier definitions that they also had to be cheap, but now I would actually say that that it pays off that they're cost effective rather than that they're cheap. And then secondary, you have a class of indicators called laboratory-based welfare indicators, or OWIs, which involve taking samples on the farm, and then these are sent to either a central farm laboratory or a central analytical or health laboratory. And this definition was first coined by Jonathan, Lars, and Martin in the first part of our handbook, Fiscal, which we will come to later. And then you can also break down you can break down welfare indicators into outcome-based indicators, so they're direct animal-based, and these can be applied at the individual level or at the group level, and also input-based, indirect indicators. So they're based upon the resources and the environment that the animals are subjected to. And what we've done recently on a project that's funded by FHF, so the Norwegian Seafood Research Fund, is we started to put together OWI toolboxes, firstly for Atlantic salmon in work done in 2017 and 2018, and then taking the same approach and the same framework and applying this to farmed rainbow trout in 2020. We released these handbooks, the last ones in May this year. And it involved scientists from Nofima, Institute of Marine Research, Norwegian Veterinary Institute, Nord University, and also the University of Stirling in the UK. Many researchers with a veterinary background, fish welfare, general fish biology background, physiology background, so there's about 15 or 20 scientists in the group. We basically assembled what we know about OWIs into toolboxes for different rearing systems, routines, and operations. And the overall aim was to give the user science-based information on the numerous OWIs and also some LabWIs for each species. Any relevant thresholds to pay attention to if they're available, and also pros and cons of using the OWIs. And then also whether they're relevant and fit for purpose for each operation or rearing system. And we try and link each indicator back, especially in the first part of the handbooks, to a specific welfare need. And the foundation of the Fish Well handbooks, well, basically it's adapting and refining a lot of existing information that was already out there. We've built on some wonderful work that's been done before, either reviews, especially by Felicity and other authors here in 2006 and Tim Ellis in 2002. Risk assessments from EFSA and also VKM in Norway. Books and book chapters, and also scientific articles and existing welfare assessment models. So we used over 300 articles in the first official handbook on salmon. And then also, last but not least, welfare standards. We leaned very heavily on those, especially in the later parts of the handbooks. We didn't do any experiments, and we didn't even try and fill research gaps with our opinions. We just collated the knowledge that we have. If there was any knowledge gap, then we highlighted it for future validation, potentially, or just to say that there was a gap there. And we split the handbooks. They were species specific, one for salmon, one for trout, as I said, and we split them into 3 parts. Part A, which is quite an encyclopedia, was to present an updated scientific state-of-the-art on the welfare of farmed salmon or trout in relation to the welfare needs at different life stages. And this was led by Lars Steen, Jonathan Nilsson, and Martin Iversen. And from the suite of welfare indicators that were available for each species, they assessed which are operational and which are fit for purpose. And then we generated an OWI toolbox here on the right, based on input environment-based OWIs or outcome animal-based OWIs, either at the group level or at the individual level. Then we took this toolbox and refined it. Either we refined it for existing and emerging production systems. This was work led by my colleague Jelena Kolorevich and Lars Steen again. And the production systems that we're looking at could be flow-through, could be RAS, submersible sea cages, snorkel sea cages, cages with lice skirt, and also traditional open cages. So they looked at 7 production systems in total. And then in part C, they looked for same approach again, and work that was led by Kristina Gizmovic from the Veterinary Institute for salmon and with regard to trout. It was led by Jimmy and Stina as well, and took the same approach, identified and described fit-for-purpose indicators for different existing and emerging routines and operations. And here's some of the examples of the toolboxes. This is just a basic example of how you would apply the toolbox to a flow-through system for Atlantic salmon, and also how you would apply it to a RAS system. So a lot of the toolbox is quite similar, except for RAS, because you're recycling and reusing a lot of the water, then there's a lot more attention paid to the input indicators, the environmental-based indicators. So there's a wider range that you need to look at and pay attention to. Jelena and Lars wrote about 10 pages per system. It doesn't need to be cross-referenced, and hopefully they're quite user-friendly. And, you know, this is just the start. That these toolboxes need updated all the time. So at the time we didn't include ozone, and we didn't include hydrogen sulfide, H2S. When you look at part C, here's an example of a similar toolbox for crowding. So again, we had 5 to 8 pages per routine or operation. It covered crowding, grading, vaccination, anesthesia. Also, at the time, what we classified as emerging handling for salmon, so a lot of the non-medicinal delicing treatments. And we broke it down into these environment, group, and individually based. So here's one basic toolbox of crowding. There's also a crowding behavior scale here, similar to the one that the RSPCA used, but this one's specific for trout, which was developed by the Humane Slaughter Association. And those are the handbooks that we've done. There's only 2 species. that don't look at, we don't try and weight the indicators for how important they are or anything like that. We haven't done any further refinement. We've said these are the indicators, these are the toolbox, and this is the collation of toolboxes that you can apply to each species. And we know already that this approach is been adopted for other species such as bass and bream by Michaelis Pavlidis and Athanasios Samaras. I think that handbook's going to come out some point this year. And as I said, these toolboxes are just the start. Where next? You know, we need more R&D to better identify potential threats, generate new knowledge, fill the knowledge gaps, and then we can refine, adapt, and integrate different toolboxes, really evaluate their application to new challenges and rearing systems. Or, you know, can we revisit existing challenges with more refined tools? We need to look at all the range of different rearing systems that are coming online, offshore, on land. Are the toolboxes we have good enough? Can they be better? Do we need fresh tools? Do we need to look at problems with take a different approach to the problems that are potentially encountered? And then also what to do with this data that we're generating. So firstly, you know, you can look at what tools are emerging now. Are new tools needed? Well, yes, all the time. They can help us learn more and more about the fish's needs, and they can also help us identify and manage welfare risks. So there's been some new research in 2020 that's quantified the effects of wave action upon fish behavior and welfare. So this is particularly important for systems that will be more and more exposed, and as they potentially move Atlantic salmon rearing further offshore. There's also other environmental based OWIs that are being identified, such as levels of ozone for post-smolts in brackish water. This is work done by my colleagues here in Nofima, Kevin Stiller, Yelena, and various others here. Basically establishing indicators and thresholds for this input-based OWI. And then also when you start looking at the animal, you know, there's different ways to look at the animal. You've got all of the external welfare indicators, but you can also start looking closer at internal morphological OWIs. So there's a nice paper here by Turi Murkora and colleagues that they've developed a liver scoring scale and also a visceral fat scoring scheme. So you can find out more information in the paper here. You can aim at and look at filling knowledge gaps or using new tools to revisit existing problems. And this is work that I'm involved in partnership with the Institute of Marine Research. So there's two projects that we have at the moment. We're revisiting fasting in salmon, both juvenile and in the adult stages. And this is a project led by Lars Steen at IMR. And its goal is basically to build more the fundamental knowledge that we have on the role that fasting plays in modulating welfare of farm salmon in numerous emerging and current rearing systems and routines, different life stages, and applying a wider range of tools and welfare indicators than we have before. Another one is the Crowd Monitor project. Oh, and excuse me, that project's funded by the Research Council of Norway, and it has another couple of years to run. Another project is called Crowd Monitor. It's an FHF project led by us here at Nofima. And what we're going to do is develop an updated suite of health and welfare indicators, so OWIs and LabWIs, for monitoring and optimizing the crowding of Atlantic salmon in tanks and in cages. That project's halfway through, and we hope to have the results delivered by the end of 2020. And as I said, when we moved into this section, we need to adapt or develop new toolboxes for new rearing systems. So there's a very nice paper here from Malte Baas from the Institute of Marine Research, introducing fish welfare in offshore salmon aquaculture. I can thoroughly recommend it as a read. It's an excellent paper. And the work here can be applied to the new emerging offshore production systems that are coming online, such as this one here by Nordlax. It's just one of many here in Norway. We need to also consider, in the production of Atlantic salmon on land, how do we adapt our existing toolboxes, either for producing the fish in RAS to slaughter, or for the work that's been done here by Andfjord Salmon, where they're producing the fish to slaughter on land using and pumping water from deep in the sea. Another application, again with a focus on refinement, is the existing tools. What we introduced in Fishwell was a scoring scheme that was basically a first attempt at standardizing the scoring of morphological welfare indicators across the Norwegian research partners, and using some heavy inputs from the University of Stirling as a basis for manual scoring of OWIs, both across the institutes and in the industry. What we found out when we all sat down around the table was that we all had a different scoring system, that it may have used the same indicators, but we scored them in a different way, even within some of the institutes, even within some of the departments. So we aimed at standardizing how we scored the fish and the injuries to the fish on a 0 to 3 scoring scale. But as with other scoring schemes, it does need testing and it needs validation. So there's again a new project involving many of the Fishwell partners, led by IMR, and they're going to develop and evaluate this method for routine welfare monitoring further, specifically aimed at Norwegian sea farms. Looking at, we're going to be testing the scheme, we are validating it, refining its applicability and its reproducibility, and integrating it with input-based environment OWEs and group-based outcome OWIs. And that project will finish at the end of 2021. There's also the scoring schemes out there. There was a very nice presentation 2 weeks ago at the SWILA webinar by Carolina Gutierrez-Rabadan on OWIs for lumpfish. She took a slightly different approach, used a mix of 2 to 5 point scales. So there's lots of variations on a theme. The main thing is that you select the indicator, you see that it's fit for purpose for that life stage and that species, and then you come up with a good and robust way to score it. Another thing that we've been discussing a lot recently and working a lot on in a lot of the joint projects we have is how to apply the OWIs in an operational setting. Fishwell outlined a very simple framework for utilizing OWIs and LabWIs out on the farm in a fish welfare assessment by farm staff. It was quite similar in structure to what farming companies and already fish health services may use, or existing veterinary health and welfare plans. But I just want to outline how we are developing this a little bit further as a framework and really hopefully improve its operational applicability. So firstly, we want this framework to be as simple as possible. So we broke it down into 3 levels. Level 1 are the OWIs, either environment-based or animal-based, that you can use in your daily management. Basic observations on feeding and the rearing environment, and then basic observations on fish behavior, their appearance, so individual-based indicators and group-based indicators in terms of behavior and mortality. If you don't have enough information, and the complexity increases, actually, so at each level you move from indicators towards diagnostics. So if you don't have enough information, from the outcome OWIs, then start looking at level 2 input indicators. So a more detailed assessment of the water environment or rearing practices, more detailed outcome-based welfare indicators, compromised fish, e.g. blood, mucus, for example, fecal samples, so start using OWIs. And then level 3, if you still don't have enough information, and when you have these outcome indicators are compromised, then you do need to really dive into the problem. You need expert personnel, a technical analysis of the rearing system, start identifying pathogens, look at fish health diagnosis, look at blood and tissue samples. And these 3 levels are basically aimed at fish farm personnel themselves, or fish health personnel, or the technical expert. And one thing to note is it's aimed primarily at OWIs, and the framework isn't set in concrete yet. So if you need a rapid response, you know, and a rapid response to a potential problem is crucial. So if the staff, or if you have an urgent doubt, or feel this process is too crude or time consuming, or if you're carrying out an operation that you know has an inherent welfare risk, then you don't need to go through these steps. You can go straight to level 2 or level 3 welfare indicators if needed. Another approach you can take with regard to refinement and evolution of welfare indicators is digitalization. And the next part of the presentation, I'm going to look at how we measure welfare right now and how we can measure it in hopefully the very near future. How we can improve the operational applicability, repeatability, accuracy and precision of the indicators that we have. And a nice framework to achieve this is precision fish farming. It was adopted by Martin Fuhrer and the colleagues here from the terrestrial-based precision livestock farming, PLF, with an aim of giving the farmer a better overview of the fish and their environment. So you get faster, more robust decisions. It facilitates the shift towards proactive from reactive. You get early warning of potential threats, and you can also maybe start developing predictive capabilities. All of these will contribute to better fish welfare. And when we talk about PFF, I feel as a fish biologist that at least from my perspective, that we really need to put the fish into the precision fish farming here. And a way to look at it is to basically take the toolboxes that we have now and see how we can develop them in the future. And a lot of this development can take place with these level 1 and level 2 OWIs that I mentioned within the earlier framework. So if you want to look at precision environmental OWI monitoring, at the moment, a lot of the monitoring is basically single point measurements in tanks and cages. So you need to standardize where we measure water quality and make sure we measure it where the fish are. That's very important, and around where the fish are as well. You can take oxygen measurements, salinity, temperature, all these level 1 indicators, or you can move to level 2 and start looking at more complex water velocity profiles in the rearing system and get a more detailed profiling of water quality like we have here the paper from Goller and colleagues in 2018. Another way to measure these input-based indicators is using Sentinel Fish. So this is the example of a paper from 2017 from Killian Stayfest, who looked at how Atlantic salmon respond to extremes of temperature and oxygen in a net cage in the sea in the Tasmanian summer. And if you look at the graph here on the right, you've got percentage saturation, high oxygen saturation at the surface, but also high temperature. Salmon have a preference for around 16, 17 degrees centigrade. So this preference overrides the need to potentially go into areas of the water column that have high oxygen saturations. Basically, the fish avoided these warm surface waters, and so the vertical habitat was markedly reduced. So if you don't have a full profile of the rearing system, you miss all this. So better environmental monitoring, you get data on why the fish distribute themselves the way they do within the rearing system. Another way, as I said before, is in cages. Water quality monitoring is not standardized. Sometimes only a small number of parameters are measured. So there's steps now for fully mobile monitoring systems to give a full overview of the level 1 and the level 2 welfare indicators and the parameters of the rearing system that the fish are subjected to. This can be achieved with mobile arrays like the one here, and also it can be achieved with AUVs, basically robotic fish. Potentially, you get a better monitoring and understanding of the environment. As I said, it's a full mobile sensor array. It can be deployed where the fish are. These robot fish can alter the position with the fish. And there's been work done this year that are seeing how the fish respond to these robots and these AUVs that you put in. When we move to outcome indicators, you've got automatic monitoring of group behavior using acoustic sonar technology. So there's an example here from CageEye that correlates changes in biomass distribution and fish density with fish appetite. Another group level indicator that you can look at is behavior. Compassion in World Farming, in a report this year, stated that fish behavior is an extremely feasible and useful welfare indicator, but it's difficult to quantify and relies on the skills of the observer and knowing what is normal and what is correct for each life stage, production system and water environment. There are tools out there for measuring fish behavior. There's a paper here from Tom Pinkowicz in 2011, but some of these tools may not be matured yet or widely used. We have a project now in Nofima, and many other institutes are looking and are considering this avenue of research on how we apply and how we assess fish welfare. We've recently recruited a new postdoc with a machine learning background here in Nofima, Santosh Kumaran. He's going to work in this challenge. We've been awarded a project next year with Cermaq Norway and Biosort, where we use the precision iFarm platform to help us improve our understanding of fish behavior in traditional and emerging sea cages. Individual based outcome indicators, morphological OWIs. Again, at the moment, most of the welfare scoring is manual. It involves removing the fish from the water. It's based upon assessing different categorical indicators. So we know, is this approach robust enough? Is there any variability between different operators scoring the fish, and how does this affect data quality? And also the sampling. Is the sample you get representative? Is the sample size that you have representative? And when you crowd the fish, when you net them, when you subject them to air exposure, when you anesthetize them, when you handle them, how do these factors affect the OWIs that we're interested in? So now there's numerous commercial companies that have a key objective for passive individual-based morphological OWI monitoring, such as Optiscale here, Biosort again, and also CreateView. And they're using camera-based technology and machine learning for welfare monitoring. Being able to act upon these changes in OWIs, especially these level 1 and level 2 indicators, in real time would be a fantastic gain and a paradigm shift. And an example of this is the Biosort Aya farm, which involves passive auditing and sorting of the fish. And then based on that auditing and sorting, then you can respond to what you see. So it brings individual-based precision farming to large-scale rearing. Other platforms, so I'm looking specifically here at the work that we're doing in Nofima. So we're looking at the digital opportunities and challenges that fish welfare monitoring present. So as I said, you can look at input OWIs. We've done that a little bit in Yelena Kolorevich's project Farmwell, and also in a project called Digital Aqua. We're looking at behavioral OWIs, and we're looking at morphological OWIs in 2 or 3 different projects, both internally and externally. These precision vision projects are led by my colleague Gareth Difford. Please contact him if you need any information. And Digital Aqua is led by a team, myself, Lars Erik Solberg, and Ingrid Morga from the food division of Nofima, and also Thomas Larsen from the feed technology division. And we're looking at these indicators, how to model them, how to analyze the data that we generate to refine our understanding, and also move from indicators to diagnostics. And finally, I'm going to finish the presentation with, the data modeling. With all of this data you generate, we need to start looking at it in an operational way. We can aid our understanding of the complex aquaculture challenges that impact upon productivity, health and welfare. It can speed up and enhance the decision-making process, but it's not an easy process. You need to optimize the quality of the data. It needs validated, it needs auditing, it needs processes, and there are many opportunities and pitfalls that lie ahead. So the last couple of slides now, I'm looking at some of the applications that are going on here in Norway. There's existing initiatives such as the NCE Innovation Cluster's Aquacloud, which collates multi-level, multivariate data streams into a platform for analyzing, and you can potentially analyze this data in relation to fish welfare. It's a work in process. It's a work in progress. There's a part of this Aquacloud now, Aquacloud 2, which is putting together several workflows that address the standardization needs of the industry and related to the data. So sensor data, where to put the data, what terminology and what data to collect in relation to fish health, the causes of mortality, and then also the environmental data. And much of these workflows are in synchrony with the NS 9417 standard for unambiguous terminology and methods for documenting the production of salmon and trout, which has been refined at the moment, and it's been updated to incorporate fish health, welfare, and data standardization. And then you can integrate the toolboxes that we have. You can take the OWIs and LabWIs, and you can combine them with existing health indicator toolboxes. So this gives the user a better understanding, a deeper understanding of how the fish is doing and what it's been subjected to. So you've got various handheld kits for measuring indicators that are potentially and are currently LabWIs. You've got all of these lab on a stick and a chip developments, combining, so the OWIs with mucus, skin, intestine and gill indicators. We're using these now in both Farmwell and Predictive, and they're an output of the SIS project from the Research Council. So finally, hopefully the take-home message is that we've got toolboxes now, but they still need adapted and refined, and we need to take a multidisciplinary approach. Digitalization of indicators is a fantastic opportunity, but it needs to be appropriate. And we can, in the first instance, we can look at these level 1 and level 2 OWIs. And this can open up and bypass bottlenecks potentially with regard to future welfare monitoring and the technical challenges that emerging systems may present. And finally, it's not just the industry, it's not just the researchers, we all need to work together, and all the tools, the systems, the routines, everything that we develop are for the fish, and we need to make sure that we know the needs and we can adapt to their needs and not force them to adapt to ours. And I think that's it. I've run over by a few minutes, but hopefully that's okay. If there's any questions, I can take them now, or you can send them to me by my email.
Thank you, Chris. Thank you for the presentation. You really shared a lot of important and valuable information on operational welfare indicators. I would like to open now the question and answer section. If you have some doubts or you want to know more about the things, now it's your time to ask it. Let me just, okay, but just Chris, before we start, okay. The first question will be from Alistair Lane.
Hi, Anna. Thank you. Can you hear me okay?
Yes, we can.
Hi, Chris. Thank you very much indeed for an excellent overview, which complemented a lot the ETIP webinar on welfare that took place a couple of weeks ago. I see there's a question from Jennifer, but Anna often comes to me when questions are few and far between at the beginning of the Q&A, so hopefully this might stimulate things. The second part of your presentation, coming towards real-time monitoring in combination with feeding, in combination with some of the tools like Optoscar have for biomass, real-time biomass estimation. It seems to me that the central point that you made earlier is about scoring and about getting a kind of standard for scoring, whether it's something that you can measure real time or whether it's something that you have to measure in a lab or in other ways. How will we get there, in your opinion, with scoring? And you mentioned RSPCA as being one of the standards that or certifiers that you mentioned as an input into your handbooks. Is it best working with them, the big players in the industry? How can that scoring be linked into some kind of certification, bearing in mind that welfare, of course, varies over the life cycle, over the period, over the seasons, and over the different operations that we do?
Yeah, thank you. That's an excellent question, an excellent point. I mean, already a lot of this scoring is going on. So as we said, the RSPCA welfare standards, I think they've been around since 2002. At least for salmon, and then for trout, I think since 2014. So they've already, they've been using these scoring systems for a long time and refining them and refining them and refining them and incorporating them with the environmental-based OWIs and others as well. So you don't necessarily need to reinvent the wheel. You can look at what's already out there. And see if that can be applied and adopted to the species, either that where there's a lot of focus with the salmon and trout, or also some of the Mediterranean species, and also global species. So you can have a read around on the existing welfare standards. The swim model that's been used in here with salmonids. Hans van der Vis wrote a lovely paper in 2012 on a welfare assurance scheme. Look at the risk assessments as well. They're a fantastic repository for information and knowledge. But a lot of the things are to talk directly with the farmers and the producers, because where we might fall flat, I think, and this is just my perspective as a biologist, is that it's not just scientifically validating a scoring scheme, but then it has to be useful and it has to be operational. Its validation happens out by the side of a cage or by a tank. So yeah, in terms of the manual scoring, then I think actually a lot of discussion and look at what has been done before and see if you can incorporate that or adapt it or build upon it. And then in terms of the digitalization opportunities, you know, they are. I mean, it's potentially really fruitful. You know, you don't have to handle the fish with these systems, with these underwater systems. You get standardized data. You get a really fast flow of data from the system, from the fish to whoever needs it, to either be the farm personnel themselves or further up in the farming system or to the fish health personnel. You know, you can get hundreds, if not thousands, of data points on different fish in a given day. So those, yeah, and if you apply it correctly to these level 1 indicators, that you're just scoring an injury, then I see that has been a really fruitful line of investigation.
Okay, thanks, Chris. I'll hand it back to Anna. I saw there's a lot of compliments and things in the chat congratulating you on an excellent presentation. I echo that, and I think we'll go back to the question that Jennifer asked earlier.
Answering the question. Thank you, Alistair. Thank you, Chris. The first question will be actually from Emily. Emily is asking, are industrials willing to use these welfare indicators, especially the higher levels?
So the level 2, level 3s. So yeah, there was, I mean, a lot of these indicators are in existing health and welfare plans, veterinary health and welfare plans, either within the companies or within fish health services or scoring standard bodies and welfare assurance bodies. So we've had feedback from some of the reference group and the steering group and some of the projects that we had that yeah, they really wanted a simple standardized scheme that was as fit for purpose as possible. So we've had some feedback within Norway and beyond that people are starting to take this fish well scheme, at least version 1.1 as it is now. But there's others out there and they're already being used. I think it's on a case-by-case basis for the more detailed LabWIs and the more detailed OWIs on how they're used. One, they have to be fit for purpose, and they have to generate information that is robust and representative and accurate, and also in a certain, you know, you get an answer in a window of, in a time window that is useful to you, and we see more and more that level 2s and level 3s are becoming more and more widespread, especially as people are becoming more familiar with them, and also where people see, like, okay, then this LabWI is suitable for this situation, but may not be suitable for another. So I think it's increasing more and more, especially in the fish health services and the companies themselves.
Thank you, Chris. The next one is from Jennifer.
Hi, can you hear me?
Yes, we can.
Great talk. Part of my PhD is looking at improving welfare standards for lumpfish, and something that I'm coming across more and more is contradictions between welfare standards for salmon and lumpfish. And I was wondering whether, Chris, you'd heard of anyone who was looking at developing OWIs to address the differences between welfare needs and how they would be prioritized between, for example, lumpfish or another cleaner fish and salmon.
Perfect. That's an excellent question, an excellent point. The frameworks, we do need to adapt them for each species and each life stage, and also we need to know exactly what the welfare needs are of these species. So I know there's work been done in Swansea. That was covered in the Sweeler webinar 2 weeks ago, and I think there's a YouTube presentation available on that by Carolina Ramadan. there's work there. Her and her colleagues have also produced a scoring index specifically for lumpfish. And I think the RSPCA, they're looking to either have, again, it was brought up at that webinar, that they're either going to have more of a focus in their existing standard in their update of the standards in 2021, or there might be a specific focus on cleaner fish. I'm not 100% on that, but I know something's coming from the RSPCA in 2021.
Thank you.
Thank you, Jennifer. Thank you, Chris. The next one is from Asben. Have you observed a link between welfare indicators and realized sales prices?
So, sorry, so one more time.
Have you observed a link between welfare indicator and realized sales price?
That's a good question. There was earlier work that on an EU project, Benefish, that I was involved in many years ago, so maybe 10 years ago now, where, I mean, people have always said that welfare is quality. You know, that if you look after the fish and you reduce the frequency of injuries and you reduce their exposure to welfare risk, then that echoes throughout the production chain, and it potentially echoes throughout the value chain. So, you know, we know that there are some downgrading on the filleting line and on the processing line in relation to injuries, in relation, at least in Atlantic salmon. We know that. Earlier, there was some work done where you could command a price premium for the fish if the fish conform to a welfare standard. I'm not sure that still applies. Maybe as markets mature and fish welfare, the focus on fish welfare is becoming more and more established. Maybe there's a shift that, you know, you don't necessarily gain a price premium, but then you have to focus on welfare just to potentially access that market or you know, access that supermarket and get space on the supermarket shelf. So I think there's different ways to look at it. But yeah, in the past we've always said that welfare is quality, and I know for one that at least in salmon that injuries affect the quality grading system.
Thank you, Chris. We will go just 2 more questions until the end. One is from Kano. Could I ask what kind of welfare indicators could be useful regarding hydrogen sulfate levels in ROS? There have been some mortality events due to the hydrogen sulfate in seawater wrasse, and it's not easy to detect high level of hydrogen sulfate, which is already toxic to fish. Thank you for the nice presentation and for the book.
Yeah, that's a really tough question. And I don't have the answer off the top of my head, I'm afraid. I know there are various projects that are starting to look into this. I know both colleagues, myself, are looking into it, Carlo Lozado, and there is the Control Aqua project that Nofima leads with other partners. I can try and find out. If you drop me a mail on it, I can try and find out. And but off the top of my head, I'm not sure there's anything out there yet. So yeah, if you drop me a mail, I can see and at least point in the right direction.
Okay, thank you, Chris. And the last question for today will be from Matthew. Are environmental measurements such as DO and temperature in offshore cages valuable at a single depth, or is the information only valuable when the entire depth profile is measured?
Again, a good question. It depends how representative and uniform the rearing environment is. if you have one sampling point, if the environment is quite uniform, then you may and there's low variability in the environment, then you don't need too many sampling points, because then that sampling point will be representative. But we do know that it's potentially very variable, and depending on water state. I really like these papers that are coming out on wave action, developing this further as a welfare indicator. But it's not just wave action; it's the scale of the rearing system and the depth of the rearing system. So I don't know. I think it would be on a case-by-case basis. But if the system is and the parameters are quite variable, then you would reduce the uncertainty by having a wider range of samples and a wider profile of sampling. And we see that now even in large-scale cages in more traditional systems, that you get a lot of benefits from doing a little bit of a deeper investigation where the fish are, and also it helps you see why the fish are there.
Thank you, Chris. If you have any other question for Chris, you can send me an email, or you can send an email directly to Chris. I would like to close now the question and answer section and share the screen. So let me know if you can see the screen now. So at the end of the webinar, we will do a short evaluation form. So please go to the website slido.com. We will have just 3 questions to answer, and I will stay on each question for approximately 10 seconds. Let me know if you can see the screen, Chris. Okay, perfect. So please go to the website slido.com and enter the code 11305. So this is the general question about our EAStalk series. It's not for Chris' presentation. So we are constantly working on improving our EAStalk webinars. So each feedback we get from you is really valuable to us. I would like to also mention that if you would like to propose some topic, or you would like to have a presentation in our future webinars, please send me an email on anna@aquaeas.eu. Let me go now on the second question. So the second question is, how would you rate today's presentation? It was truly excellent presentation, Chris. We received a lot of positive questions at the end, which you will be able to see once we are finished with the webinar. And now this is the last one. How lucky you will join EAS to get access to all the EAStalk webinars? I would like to mention on this question that EAS membership is free of charge for the students and retiree person. And since this webinar is recorded, it will be published on our YouTube channel, but it will be available just for 1 month. If you're a member of the European Aquaculture Society, you can see all our past webinars. So actually this is our 20th webinar, so congratulations, Chris. You will be able to see the rest of the 19th webinar and also download the presentation. Okay. And on the end, I would also like to say that our next webinar will be on January 5th with Wayne Murphy from Hedge Blue. Hedge is the world's first sustainable aquaculture accelerator program. I would like to thank you all for participating in today's webinar. I hope you enjoyed it. And thank you very much, Chris, for giving excellent presentation, as all attendees agreed with.
Thank you. Thanks for the time.